Yeah, hello everyone. So we have seen three lectures. Now based on these three lectures, we will see these questions. Okay. So I hope you have already solved the question on your own in your rough notebook. And now you can see the solutions. Okay. So you need to find the value of power absorbed and power delivered by the each element in the given figure. So there are four elements P1, P2, P3, P4. Okay. And you need to tell me the power absorbed or delivered. So tell me what is P1 doing? P1 is delivering power, right? Because the current is getting out. Current is getting out like this. So power delivered. Current is getting out from positive terminal. So power delivered. What is the power delivered? V into I, 5 into 9. That is 45 watt. Okay. Let's talk about P2. Current is getting into the positive terminal. That means power absorbed. If the current is getting into the positive terminal, that means the power is being absorbed, and if it is getting out of the positive terminal, that means it is getting delivered. So power absorbed is 9 into 2, that means 18 watt. P3, power, current is getting into the positive terminal, right? Current is getting into the positive terminal, that means power absorbed. What is the value of power absorbed here? Tell me. That is current 4 into the voltage. What is this? This is a current controlled voltage source, right? That is 0.6 into I. What is the value of I? I is 5 ampere. So that has a value of 0.6 into 5. That means it is 3 volt. This is a voltage source, right? Voltage source. So that is current controlled voltage source. Value of I is 5. So this value becomes 0.6 into 5. That means it is 3 volt, right? So 4 into 3, that means 12 volt. Now P4, what is P4 doing? Power delivered or absorbed? The current is getting into the positive terminals. That means power absorbed. Absorbed. Okay, power absorbed. So 5 into 3, that means it is 15 watt. So now you can also see power delivered is equals to power absorbed. 45 is equals to 18 plus 12 plus 15. 20, 30 plus 15, 45. 45 equals to 45. So power delivered is always equals to power absorbed, right? So this was the first question, easy question. Let's move on to this question. This is also easy. We need to determine the value of current flowing through the element if the charge is given like this. So what is IT? IT is dqt by dt. dqt by dt. So for the first question, constant value, IT will be 0 ampere. For the second question, differentiation, that would be 80 plus 20. I hope you know the differentiation and integration. Okay. Third question, differentiation of this, that would be equals to minus 45 e to the power minus 3t plus 36 e to the power minus 18t. Fourth, differentiation of this, we can write it 15 t to the power 5. So 75 t to the power 4 plus 40 t. I hope I did the right calculation. So 20 40 40t, okay, 15 5 75, yeah. Now unit, this is 0 ampere, 0 milliampere, whatever it is. This will be ampere. This will be nano ampere, right? Because here we have nano coulomb, and this will be pico ampere, right? Now moving on to the next question. Now what you need to find? You need to find the charge. The charge is integration of IT dt, right? Time limit can be there, but forget about the time limit. Okay, forget about the limit. We will solve it without limit. So here your qt will be integration 3 into dt. What is the value of integration 3 into dt? 3t plus c, right? 3t plus c. So here you can see the q of 0. That means that is equals to c is equals to 1. That means c value is 1. So your qt is 3t plus 1 coulomb. Did you understand it? Your qt is integration 3 into dt. So we got 3t into c. Now it is given that at t equals to 0 you have a charge of 1 coulomb. 1 coulomb. Okay. So it is equals to q of 0 is equals to 1 coulomb. So c value is coming out to be 1. So I just wrote it 3t plus 1 coulomb. Okay. Now similarly in the second question, what will be your qt? Just differentiate, just integrate it. So that will be t square plus 5t plus c. From here you can calculate q of 0, that will be equals to c, that is equals to c 0. So your c is 0. So basically your qt will be equals to t square plus 5t, or you can put the limit as well, but putting the limit and everything, forget about that. We can solve it in this manner only. Third question, just integrate it. So what you will get? 200, yeah, and here the unit will be millicoulomb, not coulomb, because the current is this. So it will be millicoulomb. Okay. So now integration of this, that will be equals to integrating it. Yeah. So this will come downwards, not upward. Basically this will be 2 sine 10t plus pi by 6 plus c, and it is given that q of 0 is, that is equals to q of 0 2 into sine pi by 6. Sine pi by 6, pi by 6 means 30 degree, 0 1 by 2 1. So 1 plus c is equals to 2 microcoulomb, or this will be microcoulomb only. So c is your 1 microcoulomb. So from here you can see that your qt is becoming as 2 sine 10t plus 5 by 6 plus 1 microampere. Did you get it? At t equals to 0, it is sine 30, right? Sine 30 is 1 by 2. So 1 plus 1, 2 microcoulomb you are getting, right? So not microampere, I should have written microcoulomb here. Sorry for that. Okay, simple integration differentiation is there. Okay, simple differentiation and integration. Let's move on to this question. Answer 4. A total charge of 30 coulomb flows past a given cross section of a conductor for 30 seconds. What is the value of current? I equals to q by t. 30 coulomb by 30. That means 10 ampere. You need to take care of seconds. You need to take care of units. Okay, coulomb per second is ampere. If it was minutes, then the answer would have been different. The answer would have been 10 by 60 ampere, right? Because the unit has to be coulomb per second. Okay, so you need to take care of unit. Now answer 5. Determine the total charge transferred over the time of interval 10 seconds, and it is given like this. So what is qt? Qt is integration from 0 to 10 seconds 1 by t dt. So it will be t square by 4. So 100 by 4, that means it will be 25 coulomb. Okay, just the integration with limit from 0 to t. Okay, so t square by 4, yeah, 100 by 4, yeah. Okay, answer 6. So this kind of problem we have already solved, but here also we will solve. You need to find the value of current at these particular times. So A, current at 1 millisecond, that means dq by dt, dqt by dt, the slope at t equals to 1 millisecond. Now tell me, what is the value of slope at t equals to 1 millisecond? That is 30 by 2. 30 millicoulomb by 2 millisecond. So from milli to milli it gets cancelled. So it is becoming 15 ampere, right? 30 by 2. That is the slope. Now I t equals to 6 millisecond. At 6 millisecond, what is the value of slope at 6 millisecond? You tell me. It is 0, right? So it is 0. And the value of slope at t equals to 10 millisecond. Tell me the value of slope at 10 millisecond. It is 30 by 4, but minus sign. Minus 30 by 4. Millicoulomb by millisecond. So it would be minus 7.5 ampere. Okay, just the value of slope at a particular given time, that we need to write. That's it. Okay, let's move on to the next question. We have to sketch the corresponding current. Okay, so what is current? Differentiation of this curve. So you will understand the differentiation in signal systems. Okay, but if anyone knows, he can draw, or we can learn as well. I will teach you here. In signal system you will also learn, but here also you can study. So we are doing it versus the time t. Time is in second. If the q is in coulomb, the current will also be in ampere. Okay, so we just need to write down the value of slope. That's it. For 0 to 1 second, what is the value of slope? For 0 to 1 second, 1, 2, 3 and 4. Yeah, tell me. For 0 to 1 second, what is the value of slope? 10 by 1. So the current is 10 ampere for the complete time. Okay, so the current is 10 ampere. For 1 to 2 second, what is the value of slope? 20 by 2. 10. How will you calculate the slope? Here we have 10. Here we have minus 10. 10 minus 10, 20 by 2. Sorry. 20 by 1. Time span is 1 only, na? 1. 2 minus 1, 1. So 20 by 1. That means minus 20 milliampere. Minus 20 ampere. I hope you have understood it. This is 10. This is minus 10. So 10 minus 10, 20. 20 by 2. 20 by 1. Sorry. 20 by 1. That means it is 20 ampere. And in the previous section as well, how you calculate the slope? 30 minus 0 by 4. 30 minus 0 by 4. 8 to 12 is 4. So 7.5. And it is the negative slope. So we'll show in negative. So it will be 20. Okay. It will be 20. I think I should show the value as well. This is 10 ampere we got. This is minus 20 ampere we got. From 2 to 4. So sorry, from 2 to 3. The q is constant. So what is the slope? 0. From 2 to 3, q is constant. So the slope is 0. From 3 to 4. From 3 to 4, what is the slope? It is a positive slope, right? This is a positive slope. And what is the value? 10 by 1. So that means it is also 10 ampere, right? So this is the corresponding sketch. Just the differentiation, nothing else. So the differentiation of this curve is this slope 10 ampere, minus 20 ampere, 0 ampere, and again 10 ampere. How do you write the slope? Final value minus initial value. Final value is 0. Talking about this, final value is 0 minus initial value is minus 10. Final value of time is 4 minus initial value of time is 3. 10 by 1. That means 10 ampere. Okay. Now moving on to the solution of question 8. So what do we need to do? We need to find the charge through the point. The total charge we need to find. So what is total charge? Qt is equals to integration it dt. And total charge, that means the complete from 0 to 2 seconds. So basically the area. Which area? This area. This area we need to find, right? So this area we need to find. So what will be the value of this area? So that I can write equal to into, you can write it in many ways. This I can take as a triangle, then 1 by 2 plus 10 plus 10 into 1. That means it will be 5 plus 10, 15. Now you tell me the value. What will be the value of Q? You tell me. Sorry, what will be the unit of Q? 15 is the value. What will be the unit? It will be microcoulomb, right? Here it was ampere because coulomb by second is ampere only. Milliampere into millisecond, milli into milli, that will give micro. In the previous analysis, milli by milli, milli get cancelled. So it was 15 ampere. Okay, and here it was the time was not given, so the time we already took it to be in seconds. So we write it as a function of time only. So this was the deciding factor. Ampere, so directly Coulomb. Milli-ampere, so it will be milli-Coulomb. And here micro-ampere, so it will be micro-Coulomb. Okay. So same in this manner. So 1 by 2 into 1 into 10, so 5 plus 10 into 1, 15, 15 microgram. Okay. Now ninth question, a rechargeable flashlight battery is capable of delivering 90 ampere for 12 hours. How much charge it can release? So now this one will be interesting. So how much charge it can release? You tell me. Q will be equals to 90 milliampere. So 90 into 10 to the power minus 3 into 12 hours. Hours I need to convert into seconds. So this will be into Coulomb. Did you understand it? Milli is 10 to the power minus 3. So I wrote 90 into 10 to the power minus 3 into 12 hours. 12 into 3600 seconds. So this will be the final Coulomb. And how much energy? What is the formula of energy? Energy is QV. So whatever the value of Q we get into 1.5, that will be your energy. So let me calculate it. So this is basically 3888 Coulomb, or we can write 3.89 kilocoulomb. Okay. And what about the voltage? Sorry, energy. It will be 388 into 1.5. So into 1.5. It is coming at 5.382 kilojoule. Okay. E equals to QE we have studied, and Q equals to I into T. So 90 into 12 into 3600, because we have to convert into ampere and second. So ampere into second is Coulomb. Okay. Now this question, this is also a good question. Find the charge delivered in the device between 0 to 2 seconds. Okay. IT is given. So what will be QT? QT will be 0 to 2 seconds IT into DT. So 6 0 to 2 second e to the power minus 2t into, so I need to calculate it. I will calculate it and write down the answer. So it is becoming as 2.94 Coulomb. So now what we need to calculate in the second question? For second question, we need to calculate the power absorbed. So for that we need VT. VT is tan into dit by dt. So just differentiate it and write into 10. So it will be, differentiation of this will be minus 12. So it would be minus 120 e to the power minus 2t volt, right? Tan into this differentiation, yeah, it would be minus 120 e to the power minus 2t, yeah. Okay. So it will be volt or millivolt? You tell me. It will be volt or millivolt. They have written it as a volt here. This is confusing. Look, this is not really clear here. What should be the unit? But they have already given the unit of volt. So one way I can think that the final voltage should be volt only. Final unit should be volt only. But also, what if like I by t is milli by second. So I can also take it to be second only. But the unit of tan is also not defined. Are you getting it? So let's just go like this. Okay, let's just make it ampere, and then also it will be 2.94 Coulomb. If it was milliampere, I should have written here millicoulomb. Okay, I didn't notice it here. If it was milliampere here, I should have written as millicoulomb, but now I have made it ampere only, so it will be written as Coulomb only. So now your voltage will be minus 120 e to the power minus 2t volt. Okay, this is the question. Now this is your voltage. Okay, you need to find the power absorbed. So what is power? Power is Vt into It. Is Vt into It. So minus 120 into 6. So it would be minus 720 e to the power minus 2t and minus 2t. So it would be minus 40 watt. Okay, no error in the calculation now. Yeah, 6 2 12. Yeah, okay, 12 6 72. Negative sign is already there. Okay, now in the C part, we need to calculate the energy. So what is energy? Now they are asked to calculate the energy in 3 seconds. So many of the students, what they will do, they will write minus 720 into e to the power 4 into 3. So minus 720 into e to the power minus 12. But that is wrong. What is et? Et is pt into dt. And for 3 seconds, that means from 0 to 3 seconds. So minus 720 e to the power minus 40, 0 to 3 seconds. So basically it will be 180 e to the power minus 40, 0 to 3. So now we will solve it and we will get e to the power minus 12 minus 1. Okay, now this will be our final answer. So basically e to the power minus 12 is very low value. So it will nearly be equals to 1 minus 180 only. So it is nearly equals to 0. So it is minus 180 joule. Okay. What modification did we do here is that we made this milliampere to ampere only, because having milliampere there doesn't really make any sense. It makes sense, but for VT we can't really calculate. If this volt was not given now, I could have told that yeah, my VT would be minus 120 e to the power minus 2t millivolt. But now this volt is given, so we can't really comment on this. Okay. Okay. Now let's move on to the next question. In the shown circuit, there are 4 elements. P1 is absorbing power of 60 watt. P3 is observing power of 145 volt. That means P3 is delivering power of 145 volt. And P4 is observing power of 75 watt. Now, how many does element 2 absorb? What one thing you know, power absorbed is equals to power delivered, right? What is power absorbed? 60 watt is getting absorbed plus 75 watt is getting absorbed, and let's assume P2 is also absorbing power, so P2. Okay, and what is the power delivered? This is power delivered, that is equals to 145. So P2 is becoming as 10. So that means P2 is absorbing power of element 2 is observing 10 watt power. 2 is absorbing 10 watt power. Did you understand it? Right? Okay. Let's move on to this question. You need to find the value of V naught and the power absorbed by each element. So let's find the value of V naught first. What you will do for finding the value of V naught? Just apply KVL in this loop. How will you apply? Assume any node. Let's start from here. Okay, starting from here, and just you need to move around the loop. From here you jumped 30 volt. From here you jumped minus 12 volt. You are jumping like this. From here you jumped, show the sign positive. From here you jumped, show the sign that is negative. From here you will jump and show the sign that is negative. Understood? So 30 minus 12 minus V naught equals to 0. One complete loop we have covered. So V naught is equals to 18 volts. Okay, so this is the first question they were asking. Now moving on to the second part, power absorbed by each element. Okay, so you need to know the current, although they have already given the current. Now tell me what will be the value of this voltage. 5 into I naught. I naught is 2 ampere. That will be 10 volt. And what is this? Current controlled voltage source. Current controlled by current, and it is a voltage source. Okay. Yeah. So power absorbed by each element. So first we will write, I will give the names. I will call this one as element 1, this one as element 2, this one as element 3, this one as element 4, this one as element 5, and this one as element 6. So we are writing power absorbed, power absorbed. So tell me, if element 1 is delivering power or absorbing power? The current is getting out of the positive terminal, right? And getting into the negative terminal, getting out of the positive terminal. Getting out of the positive terminal. That means it is delivering power. And how much power it is delivering? 30 into 6. but with the negative sign because we are writing the power absorbed. So it is absorbing a negative power of 180 watt. That means it is delivering 180 watt power. Okay. Now talking about P2, it is delivering or absorbing? It is absorbing because the current is getting into the positive terminals. 12 into 6, 72 watt, because it is absorbing. So we are writing power absorbed only. Okay. So P3, current is getting into the positive terminal. So 3 into V0 is 18, 54 watt. P4, current is getting into the positive terminal. 2 into 28, 56 watt. P5, current is getting into the positive terminal. That means 1 into 28, 20 watt. P6, tell me, the current is getting out of the positive terminal, getting out of the positive terminal, getting into the negative terminal, getting out of the positive terminal. Okay, the current is getting out of the positive terminal. That means it is delivering power, and that is 10 volt into 3 ampere current. This is the current, 3 ampere. So 10 into 3, that means minus 30 volt. Now these two are delivering power and these are absorbing power. Now you add them up and add these two up. Adding these two up, we get 210 volt. Now add them up, you will get 6. Yeah, these two are 110 and then 80, and also you are getting 210. So power delivered is equals to power absorbed. Okay, these two are delivering power, right? And these four are absorbing the power. Okay, good. Now in this question, the power consumption of a household is shown for a 1 day. You need to calculate the total energy in kilowatt hour. Okay, so what is ET? The complete limit PT into DT. PT curve is shown, right? PT curve is shown. So basically you need to calculate the area, right? You need to calculate the area. So how will we do that? Basically 200 watt for 200 watt for 6 hours, and from 8 to 6, 2 2 2 2 2 4 2 3 6 2 4 8 2 5 10 10 और 6 16 16 and 2 18 for 18 hours, plus 800 watt is for 2 hours, and 1200 watt is for how much hour? 1200 watt is for 4 hours. Okay, so just solve it. I will solve it. Let's see. 3600 plus 3600 plus 1600 plus 4800. And now solving this, what is the unit? Watt hour here. Here the unit is watt into hour. Hour. So the unit is watt hours. Okay. So 36 plus 16, that will be equals to 52 plus 48. That means it is 100. So 10000 watt hour. That means it is 10 kilowatt hour. Okay, this is the total power consumed. Now the average power for 24 hours. Average you need to calculate. So think about it, how you will calculate average. Think about it. Look, 200 watt of power is consumed for 18 hours, and 800 watt is consumed for 2 hours, plus 1200 watt is consumed for 4 hours. Divide by total time, that is 24. That means this 1000 by 24, it means 416.67 watt. Did you understand this? Like let's assume 2 2 3 4. You need to calculate the average of this. What you will do? 2 into 2 plus 3 plus 4 divide by these 4 quantities. So 4. This is what I am doing. 200 watt for 18 hours plus 800 watt for 2 hours plus 1200 watt for 4 hours divided by the total time. Total time is 24 hours. So this was watt hour by hour. So watt hour was 10,000, right? It was 10k and by 24. So we are getting 416.67 watt. Okay, so that's it. Now this is question 14. I will write answer 14 here. Okay, so a total of 2 megajoule are delivered to an automobile. Voltage is given 12 volt, giving it an additional charge. How much additional charge is there? Okay, express your answer in ampere hour. Okay, so basically what did you study? E equals to QE. E is 2 megajoule, or I can write 2 into 10 to the power 6 by voltage is 12 volt. That will be equals to Q. So Q you will get as 2 by 12 into 10 to the power 6. Okay, so it will be 0.16 into 10 to the power 6 coulomb, because joule by voltage is coulomb. Now you need to write it in ampere hour. Okay, so ampere is equals to coulomb per second. So ampere second is coulomb. So basically this is, so what did we get here? Q is equals to 0.16 into 10 to the power 6 ampere into second. 0.6 into 10 to the power 6 by 3600. That will be ampere into hour. How? 1 hour has 3600 second. So 1 second will have 1 by 3600 hours. So I just converted second into hour. Okay. This question I took only for the conversion. Okay. 1 2 3 4 5 6 3600. So by conversion I meant the unit conversion. Okay, nothing else. Yeah, so Q is 46.29 ampere hour. Okay, so ampere second, 1 second is 3600, so it is 46.29 ampere hour. Okay, so answer 15 we will write here. Horsepower, this is a unit of what? Power only. Okay, 1 horsepower is 746 watt. So how much does a 10 horsepower, how much energy does a 10 horsepower motor deliver in 30 minutes? Okay, so what is energy? That is P into T. So 10 horsepower means 746 watt, 30 minutes, that means in second 30 into 60. So 30 into 60 into 10 into 746, that is coming out to be 1.34 into 10 to the power 7 joule. Okay, so this much energy is delivered. Okay, now let's solve question 16. Let's see the answer of 16. 60 watt TV is turned for 4 hours. We have solved the similar kind of question during the theory only, right? So how much it costs? So tell me how much it costs. So total cost is 10 cents into kilowatt hour. So 60 watt into 4 by 1000 we will do, because we have to convert it into kilowatt hour. So basically 24 cents. Did you understand it? What is the power? What is the energy? 600 into 4. 600 into 4. This is the energy. That means it is 2.4 kilowatt. For 1 kilowatt, it is 10 cents. So for 2.4 kilowatt, it will be 24 cents. That's it. This is what we did. The total energy is 600 into 4. That means 2.4 kilowatt. Okay, 2.4 kilowatt hour, and 2.4 kilowatt hour into 10. That means 24 cents. Okay, that's it. Now moving on to this question, you have to calculate the value of current I, the resistance R, and the transconductance. Okay, so how will you calculate? This 30 volt will completely come across this 5 kilo ohm resistance, so what will be the value of I? I is flowing from higher potential to lower potential. So I is 30 by 5. That means 6 milliampere. Why milliampere? Because there is kilo ohm there. Okay. So kilo ohm is there. So it is milliampere. And this is volt only. So no worry about it. This is volt only. So 30 by 5 kilo ampere means 6 milliampere. Resistance R, R resistance is 5 kilo ohm only. It is given only. And what will be the transconductance? It will be 1 by 5 millimho. That means 0.2 millimho or 0.2 millisiemen. Why milli? Because it was kilo. So kilo, if we go upward, kilo will turn into milli. So it is 0.2 millimho. Okay. Now this question. A resistor absorbs an instantaneous power of 30 power is this given, the voltage is given. Now you need to find the value of current. Current will be P by V, because P is equals to VI, so current will be P by V. So 30 by 30 cos square omega t by 15 cos t, so it will be 2 cos t, right? And the value will be milliampere, because milliwatt by volt, so it will be milliampere. What will be the resistance? V by I, that means 15 by 2, that means 7.5, and this is volt and this is milliampere, so it will be kilo ohm. Let me write it completely. What is V? V is 15 cos t by, what is current? 2 cos t milli, that means it is 7.5 kilo ohm. This is milliampere, this is volt, this is milliampere, this is volt. So volt by ampere is ohm, and this milli will go upward, so it will become kilo. So R is 7.5 kilo ohm. So unit you have to take care of. Okay. In the examination, many times we go wrong in the units only. Okay. So we will see further question now. Yeah. Yeah. So let's see this question. So we need to tell the number of branches, nodes, and independent loops. Okay. So to tell me, if I call this node as A, what will be this node? This will also be an A only, because there is no element, neither voltage, current source, resistance, capacitance, inductance, or BJT, op-amp, nothing is there. This is a simple wire. So this will also be a node A. So this complete will be node A only. Na? And if I call this one as B, so this complete will be this and this combined. This complete will be node B only, right? So this is one node only, and this is node C. A, B, C, only 3 nodes are there. So nodes are nodes that we call N. These are 3. Now tell me about the branches. 1 branch, 2 branch, 3 branch, and 4 branch. A and B, 1 branch. This is also 1 branch, 1 voltage current source. This is also 1 branch, and this is also 1 branch. So branches are 4. And what are the loops? Loops means independent loops. Independent loops. 1, 2, 2. 2 independent loops are there. So the formula that we studied, B equals to N plus L minus 1. This is also being verified. 3 plus 2 minus 1, that is equals to 4. Okay. Very simple thing. Moving on to this question, you need to find the value of V0 and I. So these are some good questions. Okay. So how will you find the value of V0 and I? First, we will apply the KVL. Okay. So what will be the drop? The current is going from high to low. So this will be 4I, right? The drop will be 4I. And this current is flowing into the complete loop. So this drop will be 6I, right? Did you understand it? This complete current is flowing in this loop as well. So this drop will be 6I from high potential to low potential. The current I is going like this. So I will be 6I. So this drop will be 6i. So v naught is equals to minus 6i. Did you understand this point? V naught is equals to minus 6i. Did you understand this? Because the current I is like this. Or you can, what you can see, if this resistance is having v naught voltage drop, so what will be the current in this resistance? In this direction it will be v naught by 6, right? A resistance having this v naught voltage drop, so what will be the current? In this direction it will be v naught by r. I told you this concept. I taught you about this concept, right? Current will be from upward to downward. So in this direction we are having, okay, sorry. So opposite direction, from high to low potential, right? From high to low in the resistance. So it will be v naught by 6. From high to low, from positive to negative, v naught by 6, and the direction of I is in negative direction. So v naught by 6 is equals to minus I. So v naught is equals to minus 6i. You can do in any manner. Okay. This I is flowing like this. You can write the drop, voltage drop is 6i. So v naught is equals to minus 6i, or v naught by 6 is equals to minus I. So v naught is equals to minus 6i. Right? In any manner you can write. I should write it in better way. This should be small I. All this should be small I. This should be small I. This should be small I. Okay. So v naught is equals to minus 6i. Okay. And what else we can write? 12 minus 4i minus 2v naught plus 4 plus v naught is equals to 0. Did you understand it? I started from here. 0 to 12. 12 minus 4i minus 2v naught plus 4 plus v naught equals to 0. I just travel around the complete loop. If I have traveled around the complete loop, I will just add down all the voltages and make it to 0. Okay. So now I will replace this v naught with I. So 12 minus 4i, v naught with I, it will be plus 12i plus 4 minus 6i equals to 0. So 16 equals to minus ka 2i. So I is equals to minus 8 ampere. Okay. And what will be the value of v naught? V naught will be minus 8 into 6, 48 volt. Okay. This will be your v naught. Did you get this concept? Just a simple KCL KVL question. Okay. Moving on to the next question now. Yeah, this one. This is the similar kind of question. I think you can solve on your own. You need to find the value of Vx and V naught. Okay. So first equation you can write by simple KVL. 70 minus Vx minus 2Vx plus V naught equals to 0. I started from here. 70 minus Vx minus 2Vx plus V naught equals to 0. Okay. One more equation you can write. What is that equation? What will be the current through it? 10 by Vx. What will be the current through this? 5 by V naught. So we are saying that 5 by V naught current is flowing in this direction, and 10 by V naught current is flowing in 10 by Vx current is flowing in this direction. So from here what we can conclude? 10 by Vx is equals to minus 5 by V naught. Right? So basically minus 2 V naught is equals to Vx. Did you understand it? 10 by Vx is equals to 5 by V naught, minus 5 by V naught. So minus 2 V naught is equals to Vx. So here we can replace Vx. So 70 plus 2 V naught plus 4 V naught plus V naught. V naught is equals to minus 10 volt. So your Vx is equals to 20 volt. Okay. Understood? Or you can verify as well. If V naught is this, V naught is here, we will apply 70 minus Vx. Vx is 20 plus minus 2Vx. Minus 2Vx means minus 40 plus V naught plus V naught. V naught means minus 10. Are we getting 0 only. Yeah, we are getting 0 only. So this is right. Okay. 70 minus Vx minus 2Vx plus V naught equals to 0. Then we show this current, the two currents, 10 by Vx equals to minus 5 by V naught. Then minus 2 V naught equals to Vx. Then we just replaced it and got the value of V naught and Vx. Now let's solve this question. Which of the following will give you VAB equals to 7 volt? Let's talk about the first one, A. We will start from here. What is the potential of this point? VA plus 5 minus 3 minus 1. That will be equals to VB. I just told you we will start from one point and then we'll go to the, just go to the notes where we started studying KVL. I don't have that notes right now, but you can go to that notes when we started studying KVL. There you will see, I told you, you will start from one point and the point at which we get and the potential of that point we can directly write equals to that. Okay. So VA plus 5 minus 3 minus 1 equals to VB. We started from here, we reached here. What is the potential of this point? That is VB. So we just wrote equals to VB, right? So it is VA minus VB is minus 1 volt. So VAB is here minus 1 volt. I'm talking about B. We will start from here only. VA minus 5 minus 3 minus 1 equals to VB. So your VAB is coming out to be 9 volts. We will start from C. VA plus 5 minus 3 plus 1 is equals to VB. So VAB is, here we get minus 3 volt. We will start from D. VA minus 5 minus 3 plus 1 equals to VB. So VAB is here 7 volt. So yes, D is giving us 7 volts. Okay, start from any point, get to that point, and at any point if you know the potential, you can write down the potential of that point. Like again, I will tell you this thing I have already told. Let's assume I will write down the potential of this point. So from VA if I come, what will be the potential of that point? VA minus 5 minus 3. And from VB if I come, what will be the potential of that point? VB minus 1. So from here as well, VA minus VB will be VA minus 8 will be equals to VB minus 1. So VAB would be equals to minus 8 plus this minus 8 will go there and 7. Did you understand it? At any point you can write the potential by that method. Start from point VA minus 5 minus 3. Okay, this is the potential of that point. Start from VB minus 1. This is the potential of that point. Both should be equal. So VAB is equal to 7 volt. So by this method you can write down the potential of any point and forget about KCL, KVL, anything. Just write down the potential of the points. This is KVL only. Okay. Now what is the value of hot resistance for a light bulb rated 60 watt and the voltage is this. So power, I have told three formula, VI or V square by R or I square into R. Okay. So 60 watt is equals to 120 square by R. So R value is 120 into 120 by 60. That means 240 ohm. V square by R. So 120 into 120. So yeah, 240 ohm. Okay. Now talk about this question. You should solve it by your own. What is the value of N nodes? 1, 2, 3, 4, 5, 6, 7, 8. Are these point nodes? Are these point nodes? No, these are not nodes. Okay, these are not nodes. Why so? Like they actually have given, like they have made it like this now. This red. Actually, they are saying that these branches, like this, they are having the same element. I guess they are referring to this. Like they are having a 2 ohm resistance and 3 ohm resistance, total 5 ohm resistance. So they are not referring it as a node. Okay, these red dots are nodes only. Okay, in the question it should be mentioned that red nodes are dots. Red dots are nodes only. It should be given. Okay, it should be given that these red dots are nodes only. Okay, so if these red dots are node only, so 1, 2, 3, 4, 5, 6, 7, 8. 8 nodes are there. Now tell me the number of branches. Number of branches. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. Something is wrong. What is wrong? 1, 2. This will be one branch only. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Did I calculate it right? Yeah, one branch I missed there, that is this one. Okay, so total branches if we count, that is 15. Okay, branch, I am writing it as loop. This is branch. And what are the independent loops? 1, 2, 3, 4, 5, 6, 7, 8. 8 loops are there. So 8 plus 8 minus 1, 15. Okay, so this should be mentioned that these red dots are nodes only. Okay, so these red dots are nodes only. Okay, now you need to find the value of I1, I2, I3. How you will find? You will apply KCL. For finding the current, we will apply KCL. For I1, what I will do? I will apply the KCL here at node A. At node A, applying the KCL. Outgoing current by positive. 1 ampere current is outgoing. So 1 plus I1 is outgoing. I1 and minus 6 ampere is outgoing is equals to 0. Look, I didn't write it like this. I should have written it like this. Minus 6 is outgoing. That means plus minus 6 is equals to 0. What do you understand by this? This 6 ampere current is incoming. You understand like this, that this 6 ampere current is incoming. Okay. So what will be the value of I1? I1 will be 5 ampere. Or how you can think? This 6 ampere is coming, 1 ampere is going here, so 5 ampere should be going here. 6 ampere is coming, 1 ampere is going here, so rest 5 ampere should be going downward. That's it. Now for I2, what I will do? I will apply KVL at this point, at node B. Okay, at node B. I2 is going up, outward current is, I2 is outward current, plus 2 ampere is outward current and 6 ampere is out, or minus 6 ampere is the inward current. So I can write minus of minus 6, because minus 6 is the inward current, is equals to 0. So I2 is equals to minus 8 ampere. What does that mean? What does that mean? That means that 8 ampere is current is coming like this, then 6 ampere current is going this way and 2 ampere current is going this way. Okay, and this is the node B. And at node A, what was happening? 6 ampere current was coming into this, 1 ampere current was going here and 5 ampere current was going here. Okay, now talking about node C. Node C. So at node C, it will help us to calculate the value of I3. Okay, so at node C, minus 2 ampere current is outgoing, 2 ampere current is incoming, so I will write it out as negative, and I3 current is outgoing, so I3 basically equals to 0. So I3 is equals to 4 ampere, right? What is happening at node C? Node C, you can see that this I3 current is going that way, 4 ampere, 2 ampere current is coming this way, and 2 ampere current is coming from this way. Minus 2 ampere is this side, so 2 ampere current, total 4 ampere current. Okay, did you understand this? Basic KCL is there. In the previous questions we were studying about the KVL, now we studied about the KCL. Okay, now in this question we will study about the KVL. Okay, you need to apply the KVL. Now the loop you have to think. You need to find the value of V1, V2 and V3. So finding the value of V1, what loop I will choose? I will choose this loop. This I will call loop 1. Okay, so in loop 1, loop L1, start from any point, start from this 40 plus 50 minus 20. I am not going upward, I am going in like this. From here I started 40, 50, minus 20 and minus V1 equals to 0. I travel around the complete loop equals to 0. So basically your V1 is 70 volt. Now I need to calculate V2. Which loop I will choose? What do you think? This loop I will choose. I will call it as L2. So loop L2 I will choose. How will I apply? Start from any point. Now you will say that this doesn't have a potential 0. Like if I have made this potential as 0, then this can't be 0, right? If this is 0, this complete line is 0. This is 0. So then this potential will be V3. I understand that. So if we apply the potential from V3, so this is V3, then V3 plus V2 plus 20 minus 30. We started from here, V3 plus V2 minus 20 and then minus 30. And we reach to the same point. What is the potential of this point or this point? That is equals to V3. So V3 and V3 are getting cancelled only. So if you are traveling in a loop now, then you can start from any point and don't consider the potential of that point. Let's just assume I don't consider the potential of this point. I just start. Okay, I just start from here. I don't consider the potential. I just start like this. V2 plus 20 minus 30. Okay, and then I came back to the same point. Now I started from here and came back to the same point. That means I can put it equals to 0. So, or what I can write, wait a minute, I should remove it first. So what I can write is that, or I start from any point, from here I started, plus V2 plus 20 minus 30, I came back to the same point. That means I can put it to 0. So for V2 is equals to 10 volt. Okay, so V2 is 10 volt here in loop L3. Loop, okay, first for finding V3, what loop I can choose? I can choose any loop. I can choose this complete loop. I can go like this. I can choose this loop as well. Okay, so for finding L3, we will write many equations. Okay, so if I start from here, V1 minus V2 minus V3 equals to 0. So basically V3 is V1 minus V2. That means 60 volt. Okay, V3 is 60 volt. V1 minus V2 is equals to V3. So V1 minus is 70 minus 10. That is equals to 60 volt. Or what we can do, you can write it like this as well. Like start from here, 40 plus 50. Start from where? 40 plus 50 minus 20 minus V2 minus V3 equals to 0. From here as well, you will get the same answer of V3. Okay, so this will be 90 minus 30. That means V3 is equals to 60 volt only. Okay, now you can try writing as many KVL equation you can write. Okay, so this I traveled like this. In the previous part, I traveled like this. I started from here, I traveled like this. Now what you will do, you will travel like this. You will start from here, you will go like this, you will go like this and come back to the same point. You can do this. What is the main thing here? You should touch one node only once. Okay, touch one node only once. I started from here, I went to this path. Now I came back to the same point. I touched one node at one time. Okay, let's just see. What I can't do. I go like this. I go like this. Okay, I'm going like this. Now I'm going like this. Now I'm coming back to the same point. Okay, if I come back to the same point, I should stop there. That's it. That's my loop. If I came back to the same point, that's it. That's where I should stop. Okay, so we can go to one point at one time only. Okay, so if I come back to the same point at that time, I should stop. So I did this path. Now what path you will go to? You will go to this path and write down the equation and get the value of V3. You will get the same value. Okay, so 40 plus 50, 90 minus 30, 60 equals to V3, or minus V3 equals to 0. So V3 is equals to again 60. So without involving V1 and V2 also, we could have got the value of V3 without only involving V1 and V2 from this path. 40 plus 50 minus 30 equals to V3. That's it. Okay. or what else paths are there? There could be any other path as well. So in any path you can write down the equation of KVL or KCL now. Okay, now let's move on to this problem. This is the second last problem, I guess. Yeah, so you need to find the value of V and Ix. So how you will find the value of V? So you will apply the in this loop KVL in this loop. So tan minus V minus 4 is equals to 0. So V is equals to 6 volt. Or what you can do? Tell me. Or what you can do? Or you write down the potential of this point. What is the potential of this point? 10. What is the potential of this point? 4. So what is V? 10 minus 4. That's it. 10 this side, 4 this side. So 10 minus 4. That means V is 6. That's it. Okay. 10, 4. 10 minus 4, V is 6. That's it. Understood? Right? Now you need to find the value of Ix. So for Ix, what you can do? So your 3I, what is the value of this potential? We will do it like this. What is the value of this potential? 3Ix. What is the value of this potential? 4. So 4. So 4 minus 3Ix is equals to 16 volt. From higher to low we are writing high potential 4 minus 3Ix equals to 16 volt. So from here we are getting 12 equals to 3Ix. That means your Ix is 4. And Ix is a current? Yeah. So Ix is 4 ampere. Did you understand it? Just you can write down the potential of any node. Any node you can write down the potential of. If we have considered 0 here, this is the only 0 now. This is the only 0. Now you can't say this potential can be 0. If this is 0, then this will be minus 3Ix. Only one 0 can be there in a circuit. So this is the 0. If this is the 0, then this is 3Ix, this is 4. So 4 minus 3Ix equals to 16 volt. So 3Ix is equals to 3Ix is equals to minus 12 actually. So Ix is equals to minus 4 ampere. Okay. Is equals to minus 4 ampere actually. Okay. Now this question, you have to find the value of I and the power dissipated by the resistor and the power supplied by each sources. Okay. So what you will do? You can take only one ground. Let's assume I am taking ground here. Okay. I start from this point. What is the potential of this point? 12 volt. What is the potential of this point? 12 minus 2. 12 minus 10. That means 2 volt. What is the potential of this point? 0 minus of minus 8. That means 8 volt. The potential of this point is 0 minus minus of 8. That means 8 volt. So this resistance is between 2 volt and 8 volt. So current will flow from high to low potential. The current will go like this. The value of current would be 8 minus 2 by 3. That means this should be negative, right? I is written like this. So this current is going like this. So I should be minus 2 ampere. Right? Did you understand it? I just started from here. 0, this is 12 volt, this is 2 volt. From here, 0, this is 8 volt. So this resistance is between 8 volt and 2 volt. So current will flow from low to high, but the direction is given like this. So if we are writing in this manner, we have to write in negative direction. So I would be 8 minus 2, 6 by 2 minus 2 ampere. Okay. So what is the power dissipated across the resistor? So power dissipated across the resistor, power dissipated across the resistor. What will be that value? P is equals to I square R. What is the value of I? I square 4 into R is 3. That means 12 volt. Okay. Now power supplied by each source. Okay. So I will call this source as 1, this source as 2, and this source as 3. So power supplied we are writing. Okay. Power supplied. We need to see the current now. Let's talk about first one. We need to see the current. So 2 ampere current is flowing in this manner. In this manner. 2 ampere current is flowing in this manner. 2 ampere. In this manner current is flowing. Right? So now tell me, for source 1, Is it delivering power or absorbing power? The current is getting out of the negative terminal and getting into the positive terminal. The current 2 ampere is flowing like this. So it is getting into the positive terminal for P1. So it will be minus 12 into 2. That means it is delivering power of 24 volt. Sorry, absorbing power of 24 volt. Talking about P2, the current is getting into the negative terminal and getting out of the positive terminal. So the current is getting out of the positive terminal. That means it is delivering power. 10 into 2, 20 volt. What about P3? The current is, okay, P3 will be interesting one. What do you see? The current is getting into the positive terminal. Are you sure the current is getting into the positive terminal? Talking about P3, if I make P3 here, this battery is plus minus, just notice the sign, it is minus 8 volt. And the current is getting into this terminal. What is the value of current? 2 ampere. What I will do to make this minus 8 as plus 8, I will invert the direction. This will be plus 8 and 2 ampere current is getting into the negative terminal now. So always we have to see with the positive quantity. Okay, the value is 8 but the sign has to be positive. So if the sign is positive, you can see that the current is getting into the negative terminal and getting out of the positive terminal. So P3 is actually delivering power. Okay, so P3 is actually delivering power. So that is 8 into 2. That means 16 volt. Okay. So now 12 watt power is dissipated across this resistor and 24 watt is absorbed by this. So total power absorbed is 24 plus 12, 36. And what is the delivered power? 12 plus 6, 20 plus 16, 36. So deliver equals to absorbed. Okay. So across resistor we have 12 watt. P1 is absorbing power of minus 24 volt. P2 and P3 are delivering power of 20 and 16. So that's it. Is that it? Yeah. So these are the questions. So we have solved all these questions. Now we will study further. What we will study, let me check. We will study about now series connection, parallel connection, equivalent resistance, star delta. Okay, these things we will study in the next lecture. Then we will study about some current division and voltage division, average values, or some problem of bulb. Okay, some power problem on bulb. Then these are interesting problems that they ask. Okay, so these things we will study. So in next 2 lectures will be mainly focused on theory, and also we will see some question, and then one more assignment we will have. So like that we will be going. Okay, within 10 lecture I guess we will be done with the basic concepts. Okay, I hope you are understanding the concept. I hope you are revising everything that we are uploading. Okay, and if you are liking it, please do share it with everyone. Okay, thank you.